Hello, today I will be presenting my accident report regarding the clean energy natural gas explosion. So a little overview of the accident. The accident occurred in Middletown, Connecticut on February 7, 2010. The accident was a natural gas explosion that killed 6 workers and injured more than 50 people. There was also significant structural damage to the plant and to nearby buildings. So the accident scenario: the clean energy natural gas power plant was being constructed in Connecticut. When the accident occurred, there were contractors and workers working on the plant, and they had just finished building a certain segment of piping. Work was expected to be finished on the entire plant in the coming weeks, but construction was lagging slightly behind. Before the accident occurred, there was debris in pipes that had recently been installed that needed to be cleared in order to prevent any turbine damage from possibly occurring. This was fixed by doing gas blows using high-pressured natural gas at around 650 psi to remove the debris. The natural gas was used in 14 different blows in the past weeks before the accident occurred, but this morning the natural gas accumulated in a congested area with low airflow. In order to speed up construction on the building, there was also welding going on in nearby buildings, as well as electrical power was present in the area of the gas flow. So the events that precipitated the accident: in the 10 minutes prior to the explosion, there were 480,000 cubic feet of natural gas that were released in an area that was not very well ventilated. The natural gas, mixing with the oxygen in the air, reached flammable levels, and an ignition source was soon found, leading to a large explosion. The resulting pressure wave damaged nearby buildings and injured more than 50 workers, and 6 of the workers later died from the injuries. As you can see on this slide showing the flammability diagram of methane, the lower flammability limit and the upper flammability limit is a tight range when oxygen from the air is used, but with 480,000 cubic feet being released into a small area, it's understandable how it reached an explosive level. So what were the causes of the accident? There are a couple design problems of the plant itself. Although it was still being built, the power plant was designed to use a combined cycle power system. This means that the gas that comes in turns one turbine before it's burned to heat water into steam to then turn another turbine. This means that to account for the pressure drop in the first turbine, the gas has to be at a very high pressure that's used. The exit of the gas flow additionally was in a congested area between 2 buildings with little airflow. The operating procedure issues. The ignition sources were still present in the area around the gas flow. Welding was occurring while the gas flow is happening. Also, power to nearby buildings was not turned off, meaning that an electrical spark could occur from a loose wire. The use of natural gas to clear the pipes is also an unnecessary risk that could be eliminated, but was not. There were quite a few problems with the management as well. The accepted industry procedure was disregarded by management in order to save time and money. There was also poor communication from management, and some of the workers present that day at the plant were unaware that the blow would be occurring. Training was also inadequate for employees working specifically on the gas flow, and there was not proper notification to employees, but also reaffirmation of the training the day of the gas flow as industry procedures recommend. So what are the recommendations for prevention and mitigation of this kind of accident? The immediate technical recommendations is to change the location of the gas exit to a better ventilated area so that the gas will disperse. This can be done in multiple ways. Some people will add temporary piping so that the exit of the pipe is not where it would normally be, but it is in a better ventilated area. Additionally, when the blow is occurring, there should be as few personnel in nearby buildings, but also near the gas flow as possible. And there should never be any kind of hot work, such as welding, going on nearby where the gas may reach. And also power should be turned off to nearby buildings to prevent any sparks from occurring. Also, by having the exit in an open area, any debris that's inside will not strike metal, which is another way that the ignition can occur. So recommendations for avoiding the hazard. The easiest way is to use a purge gas that is not flammable. Natural gas is very flammable, and this is also not the first time it's happened, but I'll get back to that. Using a purge gas such as nitrogen or even compressed air has zero chance of igniting because nitrogen is an inert gas and air cannot ignite in air. Additionally, this is important, as I said before, because debris, when it's exiting the pipe, if it hits metal, it can cause sparks, or if it's hitting the inside of the pipe as it is being blown out. Again, ensure the area where the gas is exiting is well ventilated, but these recommendations have been made before, which means that they were ignored when this accident occurred. There was a similar accident at Wolfskill Energy in 2003 where they did a natural gas blow and the gas ignited. So recommendations for improving management. The biggest thing is to start audits by third parties that are not involved. Obviously, the management knew the industry standards. This accident was not the first time that they had occurred, but their operating procedures were still putting workers at risk and risking an explosion. This third party will make sure not only that the operating procedures are safe, but then during constructions, the audit will check to make sure that the procedures are being followed. Another way to improve management is to ensure that every worker present at the gas flow is trained specifically for that job, and that safety tips are reinforced to all workers before the blow begins. This did not happen, and so even if they did have training, it's easy to forget some small tips here and there, and that's important to be reinforced. Additionally, they need to make sure that worker safety is put above profits. This goes beyond this accident specifically and extends to company culture. By them putting profits first and having welding going on, obvious ignition sources, and ignoring industry procedures, this isn't just a one-time thing. If they're willing to do it now, they're willing to do it again. So management needs to put worker safety first. Here's my works cited, and thank you for listening.